afternoon, everyone. Hopefully you can hear me. Hopefully you can see me, as is the traditional way of greeting each other nowadays. That and the additional, hey, can you share my screen or can you see it now? You know, this will probably become a cultural expressions that we will continue to use afterwards. Welcome to yet another online seminar organized by the European Heat Pump Association. As you know, we organize a lot of these events. They're quite diverse, very interesting all the time, and they try to include as many examples, so from projects, from policy, from startups, as possible. This situation that we're in also offers the advantage of everyone having familiarized themselves with how to participate in these webinars, and us familiarizing ourselves, as we were talking before everyone joined, on how to actually do these webinars. So welcome to the session on waste heat solutions for Europe's recovery and green transition. I've added there a word by myself from the title that you had. My name is Stefanica. I'm the head of projects here at the HPA. So some of you may already know me from the projects that we work together on, from other webinars that we participated in together, or from the Research and Innovation Committee that I'm going to blatantly just, wink, wink, join. It's a nice opportunity. Before we start, just a little bit about the agenda of today's session. So from just 10 minutes of introduction, that will be from me. Then we go right in it to the project presentations. So we'll have 10-minute presentation for the project Dry Efficiency, 10 minutes for R-ACES, 10 minutes for REWARDHeat, 10 minutes for ReUseHeat. And then you'll have the chance to interact with the speakers by a Q&A session and a roundtable discussion, of course. So first, just a small note. During the session, you might hear the concepts of waste heat and cold, or excess heat and cold, or circular energy. This will be used interchangeably at the HPA. And it's the policy team that always reminds me, because this waste heat is actually recovered and reused as part of a circular economy. We always want to change the concept and even the name to something like circular energy. We strongly believe that, for example, above a certain size in kilowatts, all these resources have to be used either on site or nearby. And you do this by analyzing the suitability of these resources. And in the case that these cannot be used, given this analysis, then they should be considered and discharged as thermal waste. Now, with that being out of the way, just a little bit of a concept on waste heat and cold. If you're here, you probably know a lot about it, or you just find out about this. I was at a very interesting meeting yesterday with 20 municipalities, and they were all looking into how they can include waste heat and cold in their respective district heating and cooling, what investments are needed, what special conditions, and if they need thermal storage, where does that need to go? So municipalities are really looking into this. So are the projects, and you will see the examples afterwards. And let's be honest, this is a resource that most often goes to waste, and this should not be the case. I mean, you can get sanitary hot water. You can have a lot of examples of heat recovery from sanitary hot water in residential applications, or the use of waste heat and cold from supermarkets, from server farms, from all sorts of industry that is already there and is already working and having these resources. The recovery of waste heat from all heating and cooling systems should be fully utilized as much as possible. As there is a lot of it, there is enough waste heat available in Europe to meet a significant part of the demand coming from industry and buildings. And then, of course, there's a lot of investments going on in this space. There are a lot of new business models. There's a lot of applications. There's a lot of live examples that are already running that we can learn from and we can replicate and use as a springboard for our own projects, right? So now, as you can imagine, we have a lot of these practical examples. And today we have selected for you 4 such projects. So these are the ones that you can see on the screen. So Dry Efficiency, ReWARDHeat, ReUseHeat, and R-ACES that are, and we are involving them in a discussion to see how and what are the opportunities and potential for waste heat and cold, how can it be leveraged using the latest technological solution, and how it is not only economically feasible, but it's economically already proven. So just a little bit of an introduction to each project, and then of course you'll hear a lot more from our speakers. So Dry Efficiency, which EHPA is a partner in as well, wants to lead energy-intensive sectors of the European manufacturing industry to high energy efficiency and a reduction of fossil carbon emissions by means of waste heat recovery, fostering competitiveness, improving energy security and supply, and guaranteeing sustainable production in Europe. The project addresses drying applications. The results are, however, of major relevance for a number of other energy-intensive industries, such as the pulp or paper industry. ReWARDHeat has the overall objective to demonstrate a new generation of low-temperature district heating and cooling networks, which will be able to recover renewable and waste heat available at low temperature. These networks will be able to increase production and distribution efficiency by recovering renewable and waste heat available at low temperature. By focusing on the exploitation of energy sources in urban environments, the replicability and upscaling potential of the decentralized solutions will be maximized. These solutions aim to promote a cost-efficient and technically viable decarbonization of the European DHC sector. ReUseHeat has the objective to demonstrate first of their kind advanced modular and replicable systems that enable the recovery and reuse of excess heat available at the urban level. The project will tackle both technical and non-technical barriers to unlock urban waste heat recovery projects and investments across Europe. There are 4 large-scale demonstrators in the project, showing the technical feasibility and economic viability of excess heat recovery and reuse from data centers in Brunswick, from sewage collectors in Nice, from cooling systems of a hospital in Madrid, and from an underground station in Berlin. Finally, our ACES creates eco-regions where multiple stakeholders engage in energy cooperation by engaging heat and cold streams, investing in renewable energy solutions, or managing energy streams with the use of the R-ACES toolbox that is aimed at reducing CO2 emissions by at least 10%. So with that short description, I'll shortly introduce the speakers that you'll be hearing from today. So firstly, Veronika Wilk, that is a senior research engineer and thematic coordinator at the Center for Energy at AIT. She leads the research field efficiency in industrial processes and systems and works in national and international research projects on industrial energy efficiency and the integration of heat pumps. She's a scientific coordinator of the Horizon 2020 project Dry Efficiency, a demonstration project for high temperature heat pumps. So welcome, Veronika. Nice to have you here today. And Baastrup Holm is a project manager of district heating related research and innovation projects at Energy Cluster Denmark, ECD. ECD is a neutral, value-creating and member-driven innovation platform for establishing and facilitating innovation collaborations between small and large companies, knowledge institutions, and public players throughout the energy sector. and has a broad experience from the district heating sector, including Danish District Heating Association, and holds Masters in Engineering from Aarhus University. Oh, a fellow Aarhus student, salutations to you. Roberto Fedrizzi coordinates the Sustainable Heating and Cooling Research Group at EURAC Research since 2009. The focus of the research team is on the design and expert control of heat pump-driven thermal plants in single buildings and in district heating applications. Roberto coordinates and participates in several Horizon 2020 funded projects, among which the project ReWARDHeat. That as well is one of the projects that the HPA is a partner in, and we're quite honored to be there. Lastly, Christina Lignerud has managed the energy department of the Swedish Environmental Institute since 2015 and is in charge of the Institute's research efforts to decarbonize district heating and cooling. In parallel, she's the chair of the DHC Plus technology platform and also conducts research on the development of business models in the sector of Halmstad University. Christina is an associate professor in industrial and financial economics at Halmstad University since 2020. She holds a PhD in business administration, risk management, and in business administration, innovation, as well as Masters in International Business from Göteborg University. So with that short description, and I hope I did a little bit of a justice to the considerable experience, both technical and practical of our speakers here today. We will start with the first presentation, please, and I'll ask Veronika to please share her screen. And Veronika, the floor is yours.
Thank you. So I will also start with that traditional greeting. Can you see my slides now?
Yes, and it's in full screen.
Okay, perfect. Yeah, so thank you very much for that kind introduction and the possibility to participate in this webinar today. So in the next couple of minutes, I will show you the Horizon 2020 project Dry Efficiency, and I also look forward to our discussion afterwards on the waste heat utilization possibilities. So I want to start with a global energy balance on industrial energy consumption. These are values from 2012, but I think that they're still valid today. So in the year 2012, 106 exajoule of energy were consumed by the industry, but only 49% were actually used. And the rest, 51%, was lost. And these losses occur in the form of radiation, friction, and resistance, but also as waste heat in wastewater and off gases. And the share of waste heat in the losses amounts to 2/3. And this is the potential that we want to tackle with industrial heat pumps. So within the Horizon project Dry Efficiency, we work on high temperature heat pumps that upgrade this waste heat to process heat up to 160 degrees C. Within the project, we work on drying processes because they are energy intensive and they are typically fired with fossil fuels. And you find drying processes in all sorts of industry. Whenever you have to remove water, drying is involved. So there's a huge potential for efficiency there. Within the project, we work on 2 different heat pump systems. The one is a closed loop heat pump system used for air drying, and the other one is an open loop heat pump system for steam drying. And on the slide, you see photographs of the industrial demonstrators that we have designed and built within the project and that are now in operation. So the red container is the closed loop heat pump used for brick drying at Wienerberger. Wienerberger is the world's largest brick producer, and our heat pump is a part of the innovation brick factory that they operate in Austria. And in the middle, you see the heat pump used for starch drying. It's located at the production site of Agrana, close to Vienna, and there we produce hot air for the starch dryer. On the left, you see the biosludge drying system that uses steam as the drying agent and an open loop heat pump to increase the efficiency. The system is operated by Scanship and it's located in Drammen in Norway. So now I want to introduce you to the Dry Efficiency Consortium so that you know about the partners who are behind this development. We have in our team 2 research and technology organizations that are responsible for the different technologies. It's AIT for the closed loop heat pump and it's SINTEF for the open loop heat pump. We have 3 different compressor manufacturers, Bitzer and Heaton and Rotrax. For the open loop heat pump, we use water as the refrigerant. And for the closed loop heat pump, we use a synthetic refrigerant that is provided by Chemours. And we also have a lubricant specialist as a part of our team, Fuchs Schmierstoffe. For the open loop heat pump, there's also a plant engineer and systems expert to integrate the open loop heat pump best into the process. And then a very important part of the project, our 3 end users, the demonstration sites that I've just shown you, Agrana, Wienerberger, and Scanship. And finally, we have 2 experts on dissemination exploitation. It's RTDS and EHBA, who's also hosting this webinar today. So let's have a closer look on the technology. And here you see a sketch of the closed loop heat pump. I want to start with the evaporator because this is where the waste heat comes in. We use waste heat with temperatures around 80 degrees C to evaporate the refrigerant. Our refrigerant is Option MZ, which is the trade name for R1336 MZZZ. It's a low GWP refrigerant that was developed for high temperature applications. We test 2 different types of compressor technologies in the demonstrator. So the heat pump at the production site of Wienerberger is operated with piston compressors, and the heat pump for starch drying is operated with screw compressors. And for the compressors, we also need a lubricant that has been developed by Fuchs. In the condenser, we deliver the heat for the industrial drying process. And our prototypes have a heating capacity of around about 400 kilowatts. So it's not the full heat supply of the drying process, but a share of it. For example, for the starch dryer, the heat pump supplies 10% of the energy that is needed for drying. And due to the size of the heat pump and also to be able to measure exactly the heat supply temperatures, we have integrated the heat pumps with an intermediate water cycle. So the heat pump provides hot water, and that hot water is used to heat the air. And within that water cycle, we already were able to measure the 160 degrees C of heat supply temperature that we were aiming at in this project. So this is how the open loop heat pumps look like. And this is the research work of SINTEF. And here I want to start on the left side with the steam dryer. So in a steam dryer, hot steam with up to 160 degrees C is fed into the dryer. And that steam is used to evaporate the moisture of the goods that should be dried. At the exit of the dryer, we have then steam at a lower temperature and pressure, and excess steam that was formed from the water content from the product. And this excess stream is recompressed using a steam turbocompressor that was developed by Rotrax. It's based on a turbocharger technology that's originally coming from the automotive sector. And one important aim in this development is to have a compact design that enables a cost-effective product. And it's also important that it's an oil-free compression design. And with 2 compressors, we reach a temperature lift of 50 to 60 K. Here you see the benefits of heat pump integration and waste heat utilization. This is a comparison that we have calculated based on the operation values of the Dry Efficiency heat pump at Wienerberger. Compared to a natural gas burner. So it's a gas burner that delivers the same amount of heat as our prototype. And on the left, you see the reduction in end energy and CO2 emissions as a function of the heat supply temperature. So we have operated the heat pump ranging from 120 degrees C up to 160. And at 120 degrees C, the emission reduction and the end energy consumption is reduced by 80%. If we increase the temperature, we need more electricity, but still we save more than 65% of the energy compared to a natural gas burner. And on the right side, there we have the energy costs. The blue line are the results using typical Austrian average values for energy prices in industry. And the red and the gray line include also a CO2 price. So the red line includes a CO2 price of 24 euros per ton, and the gray line an increased CO2 price of 50 euros per ton. And when we look at the savings that are possible at the highest heat supply temperature, we start at 10% cost reduction with the current condition. But with the increased CO2 price, we can get more than 30% of energy cost reduction. So this also emphasizes the CO2 saving potential of heat pumps that also can be converted into a financial benefit. The heat pump technology that we work on in DryFiciency is not only suitable for drying processes, but for all sorts of industrial processes that have waste heat available and that need process heat up to 160 degrees C. On the right side, you see a map of Europe that I've taken from the Heat Roadmap Europe project, because it's a very nice visualization of the excess heat activities in different industrial sectors. So there is waste heat available all over Europe. For example, in the chemical and petrochemical industry, food industry, paper making, metal production, metal treatment. And within the project, we also had to look at the market potential. So we did this calculation based on statistical data that's available for the industrial energy consumption, and also values for the waste heat that could be recovered. And we had to look at two different scenarios. So the scenario one is the baseline scenario based on the current condition. It's shown here in light blue. And the scenario two is the future scenario, which implies an increased CO2 price and also lower investment costs for the heat pump, because we believe in the economy of scale, and then also some learning effects. And it's interesting to see the differences between the two scenarios. So we assumed that the heat pump should have an amortization time of 5 years to be interesting for industry and to be really chosen as an efficiency technology. And with the scenario 2 and a share of recovered waste heat of 30%, we calculated the number of heat pump units that could be installed in Europe, and this sums up to more than 8,000 1 megawatt heat pump units, which is a very interesting potential to be realized in the future. So this was just a very brief introduction to the DryFiciency project. If you want to know more about our work, I kindly invite you to join us in our webinars that will take place in April. So there will be one on the components and another one on the demonstration plants. And then we also have our final conference on the 6th of July. The conference will be held online, and I will be happy to meet you again at our conference. Thank you.
Thanks so much, Veronika. And indeed, some very, very interesting events that we strongly recommend. Not because we're organizing them and you have such nice speakers, but because, of course, they would be very useful for you. Thanks again, Veronika. Again, if you have any questions during these presentations, please feel free to put them either in the chat box or the Q&A here on Zoom. I'm sure we all know how to do that. Moving a bit forward with the next presentation from R-ACES and Anne. Anne, please, the floor is yours.
Thank you. You should be able to hear me and see my screen now.
Yes.
Perfect. Well, I'll just say thank you for the opportunity. I just want to introduce, well, you already introduced myself, but the REUSEHeat is coordinated by ISBT, and we are, I'm working at Energy Cluster Denmark as a project manager, and we are a partner in the project. And there you go. The next slide. It's a Horizon 2020 project as well. It's coordination and support action. So compared to some of the other projects, we're not building anything. We are offering a lot of support and different tools that can accelerate some development regarding energy efficiency. We started last year, 7 partners from 5 different countries. So as well, we quite agree upon, there's a lot of European potential for reducing our energy demand. The industrial sector contains of over 25% of the total energy demand, but only 16% come from renewables. So not only we need to save energy, but also need to be more efficient and save emissions. We do that in the REUSEHeat project. I call it REUSEHeat. I know you said R-ACES, it doesn't really matter. Through energy cooperation as the solution. So we're aiming at having industrial site and business park to be involved because they play a key role in the energy transition, as we hear also from the other projects. The industrial parks and business sites have a potential to become these hubs for the regions they're located within. So the vision of REUSEHeat is to support the industrial site and business park and the cities to become eco-regions in order to reduce their CO2 emission by at least 10%. That are our aim with the project. So we are aiming at creating the eco-regions. Eco-regions is a new term. I'll get back to the definition, where we engage multiple stakeholders. And I'm glad that you mentioned the municipality earlier, Dan, because it is a very important stakeholder in energy cooperation, aiming to exchange heat and cold stream, invest in renewable energy solutions, and manage energy streams. And we're hoping to do that by the use of the different toolboxes in order to reduce the CO2 emissions. So there's an approach, a rollout plan, and we are starting with the insights from different projects, and we have gathered and researched a lot of projects in order to condense the previous knowledge. Right now we are developing the tools. It's 3 practical tools, and I'll tell you a little bit more about that in a minute. The tools and the process will be validated in 3 eco-regions that are part of the project, and throughout the project we'll expand to 10 eco-regions and further distribute the knowledge and tools to 90 high-impact regions, which is also based on the Heat Roadmap Europe. So that's a very important work that has paved a lot of projects and further communicate the result worldwide. An eco-region, it's a new term that we are defining as when multiple organizations are cooperating in an eco-region in order to establish cooperation of energy activities. It's often linked to its surroundings, and that is typically through district heating networks, but it could be in other types of activities as well. An eco-region often relies on an anchor organization that is responsible in the area. It can be a manager of business parks, it could be a municipality, it could be different cluster organization. The type of organization is not that important. The importance is that there's an anchor that ensures that the stakeholders is connected. I just wanted to mention the 3 eco-regions. It is Nyborg in Denmark that has a long experience in utilizing excess heat from the industrial parks in industrial sites in the area. And Antwerp that has a very high potential for utilizing excess heat. And Lombardia. Lombardia actually consists of multiple cities and areas, all with district heating networks available and an extensive amount of excess heat. We are developing 3 different tools, as I mentioned. The tools aiming to support the entire process of organizing an eco-region and establishing the collaboration. And this is our effort in order to support the support and coordination action. The 3 different tools, I just run through them here. The first is the self-assessment tool that helps to identify the potentials. It also includes checklists for users and stakeholders to help them kick off the process and ensure that they are on track in order to get an energy cooperation going. The legal decision support tool supports the stakeholders in drawing contracts when that time comes, and help to get all the assignments and getting the agreements going. And the third tool is energy management platform, that is very key in order to manage and optimize the energy flows between the companies. They are currently being developed and are being tested at the moment, so very shortly they will be online, and I'll let you know where to find them. Sorry, that was just the different tools. I just mentioned them. I'm just gonna move forward. We would very much like more to be a part of it, and for us to be able to reach out, and hopefully you'll join us by sharing commitment. And you do that on our webpage, r-aces.eu. You go to the eco-regions in the top menu, click on share your commitment, and fill the form and submit, and then you'll be visible in the map on our webpage. And you can then, the more people that fill in the pledge here function, then you can see where other stakeholders in your area that are engaged in energy cooperation, and get the collaboration going. This is very, of course, early, so we will, along the project, there will be additional eco-regions and stakeholders showing on the map, and it will help accelerate the collaboration throughout Europe. Yes, we are hoping to accelerate the energy cooperation for maximum input through the commitment. So you don't commit to actually invest in anything, but you share your engagement and make yourself visible to other participants. I will just want to mention our training material. We'll have an online educational environment with a lot of training material to support capacity buildings. And it's actually based on a lot of other projects as well. So it's not just the REUSEHeat information. We're looking to all your projects as well in order to link. And of course, we'll check with you that it's okay to have the materials. There will be two types of material, training materials and a serious board game. And the game you can play with stakeholders in your region in order to get knowledge of what is needed for an energy cooperation. Please follow our webpage, and you can get more news about the project on our Twitter, LinkedIn, and YouTube accounts. And you can always get in touch with us through the webpage, and and you have my contact information as well if you have any questions. Thank you for your time, and I hand it over to you.
Thank you, Anne. Indeed, quite interesting, especially the concept of eco-regions and just the easiness of finding other stakeholders that are involved in the work that you do. This is actually part of the, let's say, the solution. We have tools as well like this, and people always ask for examples of projects or for people that they can collaborate with, and these are really already available for some time. If not, they are already becoming and being put online. So the collaboration aspect of, let's say, problems that we're all facing is becoming more and more easily solvable. So just another example, and I will check afterwards the board game. You know, we're stuck at home, so that for sure will be helpful. Thank you again, Anne. Moving to the next presentation, and I'm going to hand the virtual scene and the virtual microphone to Roberto. Roberto, please, the virtual Zoom floor is yours, please.
Thank you, Dan. See if I can run it. Okay.
Looks great.
So, good afternoon all. I will go through the presentation. Introduction was made by Dan before, so no need for that. I will talk about another application for waste heat, which is in district heating and cooling networks. And in particular, what we do in REWARDHeat is to look into how to recover low temperature waste heat. So a little different application compared to what Veronika presented before. And this starts from the fact that people live in cities. 72% of us live in large cities or towns. And over there we have a large a huge amount of low-grade waste heat, which is available, which is coming from air conditioners, from industrial processes, tertiary building chillers in refrigeration systems, and so on and so forth. Plus, we have obviously a lot of low-grade renewable energy, which is available from rivers, lakes, and seashores. And then again, it is valuable to look into how recover this energy and use it. To do this, the vision is that we need to work with district heating and cooling networks that work at the supply heat at low temperature, which is lower than conventional for sure, but even possibly lower than 40-50 degrees, which is the temperature which is used for space heating and for domestic water preparation. And again, what we want to do is, since we can work at supply temperatures that are lower than conventional, we can also aim to find technically and economically suitable solutions for recovering waste heat which is available at lower than 40 degrees, which is somehow the majority of the waste heat which is available in our towns. So to do this, we decided that we needed to work in a very systematic way and to address all what are the main barriers to reaching the goal, which is 4 main barriers as we identified and as you will see in my presentation. The first of which is when you design a new network or when you expand a network, you need to understand what waste heat you will have available on the track of the pipelines, first of all. And second of all, you will need to understand how much waste heat you will have available through the day and the months and year that you can reuse in your network. That is not easily done normally because this information is not available. So basically, what we are working on now is on mainly these 2 topics, which is a database of planning schemes and waste heat sources, and on the other end, on a pre-design tool. With respect to the first, basically what we are gathering is best practices in terms of how to recover waste heat from different sources. For example, here you see the diagram of, oops, I cut the legend. Temperature in summer and winter out of a refrigeration system in a supermarket. And basically the electricity consumption follows. What we are doing is to try to understand what kind of substation can be installed in the refrigeration system to recover it in different kind of district heating and cooling networks. What is the equivalent COP, which is what is the amount of electricity that you need to recover this waste in the network, depending on whether you have a heat pump or not in the substation. And basically, we want to, out of this, what we want to do is to provide a distribution of waste heat available at what temperature during the year. What we are trying to do on the other end is also to link this information to OpenStreetMaps that you can link to your GIS tools. A utility can link to their GIS tools. And again, we want to link the information on the waste heat available and possibly recoverable to the location itself of the waste heat itself. In a way that this is really starting point for planning the integration of a source into a network which is passing by. On the other end, there is no really clear indication in terms of how to design, size a substation to recover waste heat, for example. And this is on the small size substations that you can install in single buildings at the supermarket or in the office buildings to recover waste heat from air conditioning, nor at large size level, which you can install in district heating plants, in large plants. Plus, again, there are no really clear indication in terms of how to use storage to match availability of waste heat and thermal loads on the network or in the single building. So we are working a lot on this, and one of the main activities we are having on the small size level, meaning on substations up to 50 kilowatts, which you can install in single buildings, is to define design scheme on the one hand, but also to work together with companies like Danfoss and E.ON to the elaboration of prefabricated substation, prefabricated skits that you can build in a factory and then bring on site, and in this way, say, reduce manufacturing and installation costs. Third point here, third barrier that we encounter when we want to address waste heat in district heating is that in this case you have multiple energy sources to the energy inputs to your district heating, which is a leap forward compared to conventional networks that have only one central thermal system. And then obviously, if this is the case, you cannot simply believe that you can switch on and off the main gas boiler or CHP unit as you do normally in conventional networks. You need to really operate and manage every single source and sink in the network in a proper way, in a very detailed and in a very continuous way through the day and hours of the day. So for this, actually, you need smart metering on the one hand, which allows you to get real-time data available, and then you need to have tools that allow you to gather this information and analyze all this information all together, which allows you then to work on managing the network in a proper way. And to do this, again, on the one hand, we are working on this data mining tool. You see some screenshots out of that on the right side of the screen of the slide. The data mining tool by our partner Artelis is basically a database which embeds also analytics and a user interface, which allows basically to gather together all this information from multiple energy sources. In this case, you see only smart meters from customers. That is an easy application. It allows to calculate real-time the performance of the network and calculate KPIs that are useful to take wise decisions in terms of how to manage the single substations and the network overall. And this is basically ready. Based on this, what we want to work on is also to develop smart controls. So basically to predict the loads for the hours and for the next hours and the next days. And in this way, take decisions on how much energy you need to store, how much energy you need to use and distribute at what temperature during the next few hours. Finally, and not less important, however, is the economic perspective and the economic barriers. So on the one hand, we need to understand how to sell it to final customers in this kind of new net or new or innovative networks, so to say. And we are working on defining business models to sell it as a service on the one hand. On the other hand, we are also needing to go through the main barriers to overcome when it comes to recovering waste heat, which are many and difficult to overcome. And again, I wanted to report on them here because we are talking about waste heat today. A few of the main barriers here are, on the one hand, that there is a split between property owner and waste heat owner in a single building. This is most of the cases, their case. And again, in this way, there is a split of interest, which is then a barrier because it is difficult to address the right person and convince him or her to connect to the network. On the other hand, it is quite difficult to calculate the economics of waste heat which is recovered in a district heating network because of the risk on the one hand that you need to take into consideration, the risk of the company, for example, or the supermarket leaving from the site. On the other hand, because there are different financial cycles related to one company, to a manufacturer, and to the utility company. So normally a manufacturer has amortization times and financial cycles that last something like 3 to 5 years. A utility company has a financial cycle that lasts 10 to 20 years, depending on the company itself. The last point, and this is more on the legislative point of view, and therefore there are different expectations, obviously, in terms of the kind of contract and the kind of revenue stream that you can, that they imagine, basically. Again, what I was saying, the last point is more on the legislative part, and which is basically waste heat in the European directives. Waste heat is not considered as a renewable energy. Plus, it is not very clear the definition and the methods to calculate how much waste heat can reduce CO2 emissions of a district heating network. And this doesn't make really easy to calculate financially what are the benefits for the network and how much, for example, CO2 credits this waste heat could pay. We are working on that, and hopefully we are going to be ready in a year from now with some good ideas how to overcome this barrier. We are having 8 demonstration cases where we want to test the different technologies and approaches I spoke to you. I don't want to waste more than your time, more of your time. So if you are interested in, you can look into our website and eventually come to me or to Christina, who is also a partner in the project, for any questions on our activities. And thank you for listening to me.
Thank you, Roberto. Pleasure as always. And again, a lot of work being done in the ReWARDHeat project, a lot of pilot sites, a lot of interesting ideas relating to prefabricated heat substations, to thermal storage, which was one of the topics that were was on the agenda yesterday with all the municipalities. They had a lot of interest on where does the thermal storage go when associated with waste heat from industry. This also, of course, being related to the price of real estate. So they needed to put the thermal storage underground, and then where underground, and then maybe use the buildings as thermal storage themselves. So a lot of ideas there, and hopefully the decision makers are also keeping an eye on this. I know that the EHPA policy team is trying to tackle the one of the barriers that Roberto just showcased. So thank you again, Roberto. If you have any questions, as always, just put them in the Q&A, and we'll answer them right after the last presentation from Christina. So Christina, please, the virtual Zoom floor is yours.
I discovered I was muted. So thank you very much. I'm here to share experiences from the ReUseHeat project. Let's hope it's working. Oh, yes. So we will talk briefly about the ReUseHeat project. What kind of project is it? We will talk about urban waste heat potential, because this is our focus, and then some learnings to date. So for the overview, this picture here summarizes our vision for future cities. And in the future, we think that there will not be so much waste heat that is not being recovered, because this is the heat source that will dominate. For example, we do not think that there will be a lot of incineration of waste or biofuels or fossil fuels. So we have to do something else. And here you see our waste heat sources from the urban context. We look into waste heat from sewage water, from data centers, from service sector buildings, and our example is hospital, and also from the metro system. And it's an innovation action, so we will demonstrate first of their kind advanced modular and replicable systems enabling the recovery of these heat sources. We have partners from 9 countries. It's a blend of academics, industry, and associations. It was a Horizon 2020 project, and we were first 48 months, but with an extension now to 60 months due to COVID delays. And we have 4 system innovations. And in this context, it's relevant to mention that they are all based on booster heat pumps, recovering low temperature waste heat into district heating systems. Well, we expect results beyond the technical aspect. For example, we have identified the urban waste heat potential for EU28. There is a lot of heat out there. And then, of course, the technical side with the demo sites, but also we have put a lot of emphasis on business models and contractual arrangements, understanding the risks of this kind of investments, understanding stakeholder interests, and also what makes this kind of activity bankable. So how much is out there? Well, according to our analysis, approximately 1.2 ETA-joules per year are possible to recover from data centers, metro stations, service sector buildings, and wastewater treatment plants. And that is quite a lot, because it corresponds to more than 10% of the EU's total energy demand for heat and hot water. And as you can see in this map on the right-hand side, there is heat almost everywhere. So what have we learned to date? Well, in terms of a number of general learnings, we have seen that there are existing incentives for renewables and for building combined heat and power installations, but there are not really incentives for urban waste heat recoveries. So it becomes almost a competition with other renewable installations. We have also seen, and I think it was Roberto who mentioned it, that there is no real framework for urban waste heat recovery around, and not for any kind of waste heat recovery, but especially urban waste heat recovery is not mentioned anywhere. then we see that the system that you need to build of the heat pump and the heat source and the consumer of heat, that kind of maturity to build that kind of system is low. Even though we have district heating networks, we had them for a long time, we have had heat pumps for a long time, but putting it together, it's not so many people who have the tradition or the skill set to do so. In our demo sites, we get long payback periods, and this is a drawback then, because then other investments are more interesting. And this is also linked then to the cost of carbon being too low. And in the future, we assume that there will be a cost of carbon, which would not make this a problem. Looking into the economic toolbox, we realized that the absence of standardized contracts, it's a problem, because every time you want to do an urban waste heat recovery, you need to invent it from scratch. So that is a big threshold to come over. And then, as always, in waste heat recoveries, there are diverging views on the value of waste heat. The prosumer often thinks that they sit on a gold mine, whereas maybe the waste heat provider, the heat provider then thinks that the waste heat is valuable in wintertime, but less so in summer. So if I return to the 4 demo sites, what did we learn to date? So in Germany, in Braunschweig, we have a computer center heat recovery. And one of the main learnings is that a very close customer dialogue is needed for understanding each other's processes. And what we also discovered is that data centers, they don't turn on everything day one, but they ramp up gradually. So that means that the waste heat is provided with increasing volumes over time, which can then lead to some lead times before you have the volumes that you wanted to recover. And then for future cases, we think that offering a cooling service to the data center rather than to purchase waste heat from them could be the key. So that would mean that the energy company would go into the facility of the data center and do all the works there, so the data center doesn't have to care, they only get the cooling as a service. So this is what we learned to date. Then for the metro system heat recovery, here we have a number of learnings. The first thing we have seen is that it's very difficult to match the heat source with the heat demand. You can have heat in the tunnel, but there is nobody close enough to make use of it. We have also identified that there is very strict safety regulations in the metro tunnels, constraining the installation to be made. And when you make it, you also have to make it really maintenance-free, because every time you go there, you will need to engage with a number of safety staff from the metro operator. And then also access to the site is restricted to a limited number of hours every 24 hours. And that is when the trains stand still, because the installation is actually made between tracks. And we also discovered an unforeseen consequence, and it is that the air in the tunnel is charged with metal dust, which impacts the heat pump design. For this particular demo site, we have a partner who is Carl Oxner. I think many of you in this context know him, and he really had to think a lot on how to crack this nut, but it was his first metro heat recovery. Then for the service sector building, we have chosen a hospital, and it's located in Madrid in Spain. And here we have learned that if you have a long-term energy service contract that you can work around together with the hospital, it facilitates the operations. Fortunately, this was the case for our demo. Otherwise, the number of permits and such would have been very large. Here we have had a hospital with 7 large buildings, and there is an own local network over which the hospital has control, which also facilitates this kind of activity. And then we also saw that hospital sector is a really challenging sector during pandemics, and we have had a horrible time accessing the site. You can imagine hospital sector in Madrid during this year has been difficult. Yes, and then our fourth demo, it's a little bit a different demo, but we included it because we think that awareness about urban waste heat recovery is very low, and we need to build end user engagement. So here we have visualization of sea and sewage water heat recovery in a network in south of France. And here, then we realize that it's easy to build a dashboard, but it's very difficult to find data that reflects what is going on in terms of energy fluxes in a district, because the data available from substations are not suited for visualization purposes. So you need to clean the data, install new substations, do new connections, and really clean up your data streams. And then there is not really any demand from the end user so far, because they don't know that they can demand, for example, heat from the sewage water or from the metro tunnel. So we will see if this will be in the end a project that somebody wants to use on the market. But then we found also that we could place this one anywhere. We could place it on any district heating network. It's very replicable, very scalable. It can be sewage water, it can be a high temperature network, anything you want to display. Yes, and those were my learnings. Thank you for the attention.
Thanks so much, Christina. Really, really interesting. And when you said about you know, not just purchasing the waste heat from server farms, but also providing cooling to them. I was just remembering, and I think we all recognize the growth of, you know, all sorts of cryptocurrency mining. And I just remembered this company that actually moved to the furthest city in the Arctic Circle just so they could get free cooling for their Bitcoin extractors. So this is something that is happening, and as you know, the electricity demand just from cryptocurrency mining is the same as the country of Argentina. So this will become far more pronounced. Also really interesting about the metal particles in the subway tunnels. I mean, unless you try to implement that, you would maybe not even think about that. So very curious to see. And what was the solution to that? Was it installing filters, or how did you solve that?
Well, it's not finally solved yet, but Mr. Oxner is developing this kind of protective layer on top of everything, so we will have minimized impact of the dust. I'm sorry, I'm not a technician, but this is my understanding of the final solution. We had to cover everything up much more than you usually do.
And then lastly, a question for you would be, you said that waste recovery from unconventional sources could potentially cover 10% or even more of the EU's heat demand. So what is needed to achieve this?
Yes, so I was thinking about this a lot because I was also in a webinar this week focusing on Sweden, where I come from, where we have a lot of existing warm district heating networks. And here we have a situation of lock-in effect, where we have the old networks and we really are not so keen going down in temperatures. The bang of the buck is limited before you start using renewables full scale. So I think in Sweden and that kind of mature market, the real thing to do is to incentivize renewables and really pushing towards that. And then in other parts, like where district heating is new, there I think it's much easier to make it happen, but you should make sure that you have legal frameworks around waste heat and urban waste heat, so people know if I invest in this, it's really green. It's as green as solar or another renewable. So that would be more on the policy side, which is lagging there.
Yeah. Thank you, Christina. A question from the audience for Veronika. It says, and I quote, for the Dry Efficiency project, is the closed loop heat pump suited for the production of steam at 160 degrees Celsius? Is 160 degrees Celsius an absolute maximum, or can we hope to go higher? If no, what are the hurdles? The compressor, working fluid? Thank you. So thank you for that question, Veronika.
Yeah, so if we think about a dry efficiency heat pump to produce steam, we would have to change the condenser first so that we don't get hot water, but we use the condenser to evaporate water and produce steam. This is feasible. For the temperature limit, so for the refrigerant that we use, 160 is the maximum because of the properties of the refrigerant. So we are moving closer to the critical point of the refrigerant. And if you look at the vapor dome, the vapor dome is getting very small at the top. So if we exceed the critical temperature, we would just change the way of operation of the heat pump, and it would change the characteristics of heat supply. So it's not feasible, but it hasn't been done yet. And we would also have to, again, assess all the items that are used in the compressor to make sure that they can stand the higher temperatures as well. So it's a question of material compatibility and also of heat transfer. If you want to have steam produced with a heat pump at higher temperatures, it's also a good idea to look into a combination of the closed loop heat pump and the open loop heat pump. So use the closed loop cycle to produce steam, and then add the open loop heat pump, a mechanical vapor recompression device, to boost the temperature and pressure of the steam to get to higher output temperatures.
Okay, thank you so much. Another question via the chat. I guess more for Roberto. It's about the regulatory framework that you mentioned as part of the barriers, and the question is, what is missing to define waste heat recovery as a renewable energy source?
Yeah, that is a little difficult answer for me to question for me to answer, meaning that I'm more on the technical side than on the legislative side. But again, you cannot define waste heat as renewable, because whenever you have waste heat, you have somehow consumption of fossil fuel or any kind of other fuel somewhere. So imagine a refrigeration system. You have waste heat available, but you have also use of electricity to run the chiller. So somehow you have fossil fuel consumption, and you need to be able to calculate this fossil fuel consumption on the one end. On the other end, you need to be able to assign this fossil fuel consumption either to the refrigeration system or to the district heating and cooling network. So it is a bit complex to handle this calculation, basically. At least this is my understanding of the story, and I don't know if you, Christina, that are more on this side of the story, or Dan also.
Well, what we saw in ReUseHeat is that when we talk to people in the EU countries of ReUseHeat, the 9 countries, we don't find anywhere explicit legislation for waste heat. And that is then a hindrance, and it creates the barrier for people to actually do it. You go for more safe options where you know what the output would be.
Thank you both. Just from the presentation of Roberto also, because you said there's kind of no link between the people that are producing waste heat or cold and the people that are using it. How can waste heat owners be incentivized to recover their waste heat?
This again more for Christina, because she is the one working on business models in REWARDHeat.
Yeah, and in ReUseHeat too. But I would say that
obviously
in ReUseHeat, we see that actually it is the waste heat owners that kind of come to the district heating companies and they say, I have this heat, what can we do with it? So I think it's not only a matter of waiting, you have to also be proactive as district heating company and see what sources are around you when you extend your network or things like that, as Roberto said, and kind of actively identify these prosumers and have a dialogue with them, because unless they are proactive and you are proactive, nothing will happen, right? So you cannot wait for them, but you should try to find them if they're not knocking on your door, even if that is increasingly happening.
Thank you.
Yeah, and from the technical point of view, I think working on solutions that are clear, how they are on solutions that clearly identify what is the installation and the consequences on the system installed, on the pre-existing system installed, and what is the consequence again in terms of risk of consequence in terms of additional maintenance or risk of failures. That is something that could help addressing the property owner in a proactive way, as Christina was saying. A typical example is for you to know the shopping mall. Shopping mall, you have a property owner that provides heating and cooling to the small shops or to the supermarket. And obviously the supermarket is the producer of waste heat, and they would be happy to tell the community that they contribute to the community benefit through selling waste heat. But again, you need to go through the property owner, so to the owner of the building itself and of the heating system itself. So these multiple levels of interest do not help, but as Christina said, in my opinion, you should go there and talk to them.
And who are the enablers of market uptake of efficient heating and cooling? So what would be the things that will push the use of waste heat? This is for all speakers. Would it be, yeah, please.
Sorry, yeah, we hope with the REUSEHeat tools and the pledge function where you can share your commitment, that it will get people engaged, and hopefully the tools, especially the self-assessment tool, where you can put in the different like what you have of amount of heat and or the heat demand, and you can have this checklist. Is there a basis of a cooperation or isn't there? And on top of that, the analyzation of the potentials that has been done both in the ReUseHeat and previously in the Heat Roadmap Europe, that maps the potential, so you have an overview and know where to find the potential, and then you can, of course, there's some regulations and some, I mean, I come from Denmark, and in Denmark there's been extensive regulations that push the renewable agenda and taxes the fossil fuels, that makes the projects very economical viable, but that's not the case in all countries. So I think some well, European national regulations that offers support for utilizing excess heat, basically.
Thank you, Anne. And I also remember from your presentation that you had a place for training, if I remember correctly. And we also see, I mean, we have a project really dedicated to that, and we also see a lot of emphasis being put on training. So what upskilling, education, reskilling trainings are needed to further advance the waste heat technologies market?
Well, that depends on who needs training, because there's a lot of technicians that are very, you know, into the whole utilization. But sometimes it's actually the politicians, the municipalities, a lot of the legal stakeholders that needs to understand why this is a good idea. So I think that is at least with the REUSEHeat tools, what we are hoping to and. There are other projects as well, as you mentioned, regarding training that aims to just what you call raise the bar of knowledge regarding heat pumps and excess heat in general.
Thank you. And then, because we're almost running out of time, but we are getting some other comments here. Of course, if you have any questions afterwards, after the webinar is over, feel free to email it to EHPA, and we'll make sure that we will relay them. So just a final question that I usually ask at these online sessions, and this is for each of you. So what should happen in the next 5 to 10 years? What would be your top 3 wishes so that waste heat and cold recovery and its utilization just moves forward? So if it was up to you, what would be the 3 main changes that can happen in the next 10 years? So let's just start with Veronika, because she's the first on my screen.
Okay, 3 wishes. So I wish for more demonstration projects for heat pumps in industry, because I think with those projects we can really make a change and really introduce a new technology. I also wish for a change in perception that waste heat is really seen as a resource to be reused again. And yeah, the third one would, well, that's not so precise, but I wish for a climate neutral society that's worth living in, that that creates a nice environment for everybody.
That was a very nice one. Anne, please. So the same question.
I agree on a lot of what Veronika said, but I think also some more general legislation across Europe could be very good. That's difficult, I know. And I think if maybe a new market design for right now, the market design for renewables well, is based on fossil fuels production, so flexibility hasn't really a market design, and I think a new market design that offers flexibility and yeah, excess heat or excess energy in general as a equal offer, that would be very beneficial.
Thank you, Anne. Roberto?
Yeah, the same ideas Anne had. For me, it would be really important to have a clear legislation at European level, and then obviously taken over by the single member states in terms of how to account for waste heat in terms of CO2 emissions, and therefore have a clear way to include waste heat into carbon credits, into the carbon credits market. That would be really helpful. And from the technology side, I think we are on the way. So that will come anyhow in the next 5 to, yeah, I would say 5 to 10 years, more 5 than 10.
Thank you so much. And Christina?
Yeah, it's not good to be last, right? Because everybody has said so many clever things. But I would say I would like to see a realistic price of carbon, because I don't think we have that today. And if we would have that, I believe that many people would be interested in investing in low temperature district heating. Stakeholders with green financing funds, I'm sure they would come our way. And then, of course, my vision is the ReUseHeat vision, that a city could heat itself with only the heat that like the inhabitants generate by walking around and living in the city.
Thank you so much. As we're running out of time, unfortunately, again, we see that there are more questions, and my colleague that is the organizer of this event will make sure that they are transmitted to the respective speaker. I thank all the speakers for their very nice presentations, for taking the time on a Friday afternoon. Friday afternoons and Monday mornings are quite difficult. And please, if you attended this, I'm sure that you have at least found out about these very interesting projects. There are very interesting possibilities that they have, from databases, from commitments, from examples, from all the pilot sites, from the visions that they have, from the speakers that very inspirationally and very passionately speak about their projects. So please feel free to check the respective websites, and I'm sure there are a lot of possibilities that there are currently opened, because we know, because again, all projects have a lot of things that you can participate in as a stakeholder, as an expert, even disseminating more the information, right? So thank you for attending the webinar. Thank you for my team, and especially Sabina, for organizing this. Again, thank you for the speakers and the presentations. You will receive all the presentations as well as the recording of this online session early next week. And again, keep posted to our let's say our newsletter at EHPA, our many social media outlets, because there are a lot of other events that are coming up, and some of these projects will be invited again, of course, to show the progress that they're doing and the technology and economical developments that are happening. Thank you again. Have a lovely weekend, and well, lovely, relaxing, and sunny weekend to all. Thank you.